direct online starter. Direct online starter is the basis and the foundation of all motor starters. It serves two faults. Number one, to switch the motor off in the event of overcurrent situations, and number two, to ensure that if there's a loss in power, that the motor will return into the off position. Direct online starter, because we're working with three-phase motors, we can connect our motor between live 1, or our first phase, and our second phase, or we can connect it between the first phase and neutral. It's up to the user's prerogative and what is available in the motor circuit. Now, looking at the circuit, firstly we will have our overload connected. That will then connect to our emergency stop. That then connects to my normal stop button. That then connects to my start. And that then actually eventually connects to my contactor with the latching contact for that contactor, MC1 connected in parallel with my start button. And then, as I said moments ago, that point there can then either connect to my second phase, or I can connect it to neutral, depending on which is available, but never ever connected to both. Now, the function of the components: the overload is connected onto the normally closed contact of the overload on the overload that's connected to the motor. When it measures excessive current, this is going to open and break all connection to the contactor that's driving it. The emergency stop is a protection device in case the user needs to stop the motor very quickly. The stop is just a normal stop button that's used to stop the running. The start is used to start the motor, and this contactor over here is a latching contact so that the start button is bypassed as soon as the contactor becomes active. Now, when I push this button, it's going to close. That's going to allow current to flow through all of these normally closed switches through the contactor, which will then activate. This activation will close that contact so that when I remove or release the start button, I have an alternate route for the current to keep that contactor energized. When it comes to the wiring of the actual circuit, I will have my 3 terminals connected. First phase, second phase, and the third phase. Okay, my first phase, or these 3 phases will all connect on the motor side. This is the control circuit side. On the motor side, these 3 phases will go through my overload contacts, and it'll go through my motor contacts, and then eventually it'll go to my motor. So we will have the red phase to the overload, from the overload to the main contactor to the motor. The yellow phase the same, and then finally the blue phase, the same. Now on the contactor over here, or on the overload, there is a normally closed contact, which is my overload. I should have drawn that symbol like that. That's my overload contact, which is going to be wired into my control circuit, and the main contactor has the normally open contact, which I will be wiring in. So from the live, it's going to go, because these three are in series with each other, their order doesn't matter. So what I'm going to do over here is I'm just going to wire in my stop button. I'm going to wire in my emergency stop button. Forgive me for not putting in the labels right now. And then that's going to go into my overload. From the overload, it connects to my start. My start button, and from the start button it goes into my contactor, and from the contactor it then connects to either phase 2, or I'm going to connect it to neutral for simplicity sake. Okay, now this contactor over here is magnetically connected to all these contacts. That's connected to the main contactor. I neglected over here, this contact over here must connect to the parallel of my start button over there. My overload is going to control that contact, and then I've got the neutral on that side over there. So this now takes my motor circuit and it looks at the control circuit. So this is how we would do the wiring in practice. In order to calculate the value that I need to set my overload on, my overload current is equal to 1,25 multiplied by I max, or the maximum current that my motor is going to require. 1.25 is so that I've got a little bit of leeway so that the starting current is not going to trip the circuit.